Alright, today we will talk about the Cramer rule, which is another method for solving the linear system of equation. But this one is very easy. So, you know all these equations in which A is the coefficient matrix we have. X is the variable, and B is the constant. Cramer rule says that if the determinant of A is not equal to 0, so it has a unique solution. And in this we are taking two determinant, but two times we are taking determinant. For example, one we have the main determinant, and then we from that determinant also we make other matrices. When we are solving the example, it will be easy for you. I'm just writing these formulas for it. This is the main determinant you will get from the matrix given in the question. So here it's saying that determinant of AI is a coefficient matrix and determinant of AI is the matrix replacing ith column by V. So what this all means, look at here now. We have, let's say, one example. We have a linear system ax plus by is equal to E, and we have cx plus dy is equal to f. This is one system of equation given to us. Solution, your first step will be coefficient determinant, let's say D is equal to, we have A, B, C, D. So AD minus BC. Here you will get one determinant. Then second step, you need determinant for dx1. In this Cramer rule, you have to find the value for x, y, z. For 2 by 2, it's xy or x1, x2, or like this. So how you will do it? Now to find dx1, BD will remain same here, BD. This will change this column. EF. What is EF? It will be given in the question, EF. These constant values. So from here you will get ED minus BF, another determinant. Then third one, determinant for dx2. So you will write here dx2, AC will come here same. Now this column will change, EF. So AF minus EC, you will get third determinant. And then to find x1, so you will say x1 is equal to dx1, this is your dx1. D is this value you got from the main determinant. So you will divide and you will get the answer. Same for x2, dx2 by d, so you will get answer for x1, x2. Let's solve one numerical, then you'll better understand it. For example, we have one system given 2x plus 3y is equal to 8, and we have x minus 4y is equal to minus 2. Solution. First you have to write it in the matrix form. We have 2, 3, 1, minus 4. This is your matrix A. Your X matrix is XY. Your B matrix is 8 minus 2. Now, first step, determinant. So you can mention A or D, doesn't matter. Let's say D determinant. 2, 3, 1 minus 4. So this will become 2 into minus 4 minus 3 into 1. So we have minus 8 minus 3 is equal to this is our determinant. Now, second one, dx1. Here we have to add EF value, these two, 8 minus 2, 8 minus 2, and here it will remain same, so 3 minus 4. So once you solve it, 8 into minus 4 minus 3 into minus 2, so we have minus 32 plus 6, so dx1 we have minus 26. Now third one we have dx2. This one will remain same, this one will change now. So 2, 1 will come here, and 8 minus 2 will come here. Now same again, determinant. 2 into minus 2 minus 8 into 1, and it will become minus 4 minus 8, so dx2 is equal to minus 12. Now once you reach here, you have to say now for x1 and x2. So x1 is equal to dx1 divided by d. Our dx1 was minus 26. Minus 26, so determinant was minus 11. So you can write here x1 is equal to 26 by 11. And then for x2 is equal to dx2 divided by d. It's minus 12 minus 11 determinant, so x2 is equal to 12 or 11. So this is your answer. Try this example. You will not forget it then. 2x minus y is equal to 17. 3x plus 5y is equal to 6.
1, 7. X2 minus 3.
Now the same we will do for 3 by 3 matrix. For example, we have one set A1x plus B1x plus B1y plus C1z is equal to D1. A2x plus B2y plus T3z is equal to D2. A3x plus B3y plus 3cz is equal to D3. Now first is determinant, you know it. So we can write A1, B1, C1, A2, B2, C2, A3, D3 and C3. Now for dx1, first row will change column D1, D2, D3. These are your D1, D2, D3 values. Remaining will stay same. D1, D2, D3, C1, C2 and C3. For dx2, A1, A2, A3, C1, C2, C3. This one will change now, second column, D1, D2 and D3. For dx3, A1, A2, A3, B1, B2, B3. Now the last one will change, which is D1, D2 and D3. So from everyone you will get one determinant value. You know that all. You will do it for first row, first column, second row, first, like this. Same. Here you will get dx2, here you will get dx3. So once you get all, so for x1, x2, x3, you will just divide by dx1 divided by d, dx2 divided by d, and dx3 divided by d. This will give you your answer. Now the same, let's do by one numerical. We have x plus y plus z is equal to 6. We have x plus 2z is equal to 7. We have 3x plus y plus z is equal to 12. Now we have to put this in the matrix form. So let's say our matrix D is 1, 1, 1, 1, 0, 2, 3, 1, 1. X is equal to x, y, z. Matrix B is equal to 6, 7, 12. step 1 determinant 1 1 1 1 0 2 3 1 1. So 1 will come outside, first row, first column, so we have 0 2 1 1. Then for the second one, -1 and 2. First row, second column, so 1 2 3 1 left. And then the last one is also 1, so third column, first row, so we have 1 0 3 1 left. So we have here 1 into 0 into 1 minus 2 into 1. We have -1 into 1 into 1 minus 2 into 3. And we have 1 into 1 minus 0 into 3. So once we solve this, we will get here for the first one you will get 1, here is -2, then -1, here you will get -5, 1 in -6, -5, this is 1, and here is 1. So we have -2 plus 5 plus 1. So we have -2 plus 6. So D is 4. Our determinant is 4. Now for dx1, first column will change with this one, 6, 7, 12, and the remaining will same. 6, 7, 12, 1, 0, 1, 1, 2, 1. Now we'll do it directly, you already know it, how to do it. First row, first column, so we have 6 here. So we have 0 into 1, this is 0, 2 into 1 minus 2. Second one is -1. Second column, first row, so we have 7 into 1. 7, 12 into 2 minus 24. Third one is plus 1. So we have 7 into 1, 7, 0 into 12, 0. Simplify it more. So we have 6 into -2 minus 1 into -17 plus 1 into 7. So we have -12 plus 17 plus 7 minus 12 plus 24 dx1 is equal to 4. Now for dx2, now this column will remain same, 1, 1, 3. The second one will change, which was 6, 7, 12, and the last one will remain same, 1, 2, 1. Again 1 will come outside. It's determinant rule. First row, first column, so we have 7 into 1. 7, 12 into 2, 24. Then second is minus 6. We have 1 into 1, 1. Minus 3 into 2, 6. Then third one is plus, so we have 1 into 12, 12. Minus 7 into 3, 21. So you will get 1 into minus 17, minus 6 into minus 5, plus 1 into minus 9. So minus 17 plus 30 minus 9. So we have 30 minus 26, so dx2 is equal to 4. Now for dx3, first one will remain same, 1, 1, 3, second was 1, 0, 1, it will same. Now the last one will change with this matrix, constant matrix, 6, 7, 12. Now 1 will come outside, so 0 into 12, 0, minus 7 into 1, 7, minus 1, so 1 into 12, 12, minus 7 into 3, 21, plus 6, 1 into 1, 1, minus 0. So we have 1 into minus 7, minus 1 into minus 9, plus 6 into 1. So we have minus 7 plus 9 plus 6, minus 7 plus 15, so we have d3 is equal to 8. Now for x, y, z, or you can write also x1, x2, x3, no problem. So let's say x is equal to dx1 divided by d. Our dx1 was 12. Determinant we got 4. So x is 3. Then for y, dx2 divided by d. Y was 4. Determinant was 4 also. So y is equal to 1. Then for z, we have dx3 d. So we got dx3 8. Our determinant was 4. So our z is 2. So this is how you will solve 3 by 3 matrix by Cramer rule. This type of linear system will given to you. Write it in matrix equation form. Then start from the determinant. Once you take determinant, then you have to keep these numbering in the mind that in the first matrix, for x1 you have to change first row, first column. For x2 you have to change second column, and for x3 you have to change third column. And you have to change with the this matrix, which is constant b, and you will get 3 different values. Just divide those by the determinant, and you will reach to the x1, x2, x3, or xyz. It's easy but a little bit lengthy. solve this. 3x minus 3y plus z is equal to 5. We have 4x plus y minus 2z is equal to 6 minus x plus 5y plus 3z is equal to 4. I need determinant value and x, y, z values. What is determinant rule? Determinant, what you got?
77.
Says Alright, after grammar rule, next we have value factorization, which is lower and upper triangular matrix. So by this method we will solve one example 2. Same, we will find all x, y, z, those values. For example, we have matrix x1, x2 plus x3 is equal to 1. We have 4x1 plus 3x2 minus x3 is 6. We have 3x1 plus 5x2 plus 3x3 is equal to 4. Write it in the standard form. 1, this is 1, this is 1. We have 4, we have 3 minus 1, we have 3, 5, 3. X is equal to x1, x2, x3. Matrix B or C or whatever, doesn't matter. It's 1, 6, 4. We have to make these zeros. So we can apply minus 4r1 plus r2. You will get 1, 1, 1 will remain same. This will remain same. Only we are doing with our 2 operation, so it will become 0, minus 1, minus 5. Then we have this 3 here, so we can apply we will get 1, 0, 0, 1 minus 1, 2 you will get 1 minus 5, 0. Now this left, so you have 2r2 plus r3. With this operation when you solve it, first one will become same, second one will remain same, third one will change, 0, 0. Minus 10. You have to multiply 2 with this row and then add with this row, so you will get this one. So this is your matrix now. Now for matrix L. L is equal to 1, 0, 0 and 2, 1, 1, 0 and 3, 1 and 3, 2, 1. One zero zero 1 0 1. Now here you have to keep in mind that once you do this row operation for the first one, just you have to take these values and change the signs. 4, 3, 2. So here it was -4, -3 and 2. So here it will come 4, 3, sign change, and it was 2, so we will do it -2. Now we want to calculate it more, and we will suppose one matrix. Suppose that this is one matrix. We have Z, Z1, Z2, Z3 or Y, whatever, it's up to you. So we have now Lz is equal to C and Ux is equal to Z. L is this matrix, Z is this matrix. Now multiply with each other. So Z1 into 1, this will come Z1 plus 0 plus 0. Then for 2, this is 4. Now for Z1, this is 1, so Z2 will come there. And this is 0 here, so it will stay 0. Then for Z3, so 3Z1 minus 2Z2 plus Z3. And this C matrix which was given here, this one, 164, 164. Now we have to put them in the equation. The same we did in the Gauss elimination. Z1 is 1 here directly, so you can write here Z1 is equal to 1 is equation 1. Then you have 4Z1 plus Z2 is equal to 6 is 2. We have 3Z1 minus 2Z2 plus Z3 is equal to 4 is 3. Now we don't need Z1, we already have Z1. So now for Z2, we will say that in equation 2, put equation 1 value. So this is 4Z1 plus Z2 is equal to 6. Now you have Z1 here, so 4 into 1 plus Z2 is 6. So once you solve it, you will get Z2 is equal to 2. Now we have in equation 3, put equation 1 value. So we have 3Z1 minus 2Z2 plus Z3 is equal to 4. So we have 3 into 1 minus 2. Now we have Z2 value also. So this is 2 plus Z3 is equal to 4. So 3 minus 4 plus Z3 is equal to 4. So we have minus 1 plus Z3 is equal to 4. So we can say that Z3 is 5. Now we get matrix Z, which is 1, 2, and 5. Z3, Z2, Z1. Now we have to solve this one also. Ux Z U is this matrix. So Ux is equal to Z. U is the matrix we calculated, which is 1, 1, 1, 0, minus 1, minus 5, 0, 0, minus 10. X given in the question x1, x2, x3, and Z is equal to 1, 2, 5 we just calculated here. Okay, again, just multiply this with x1, and so it will become x1 plus x2 plus x3 is equal to 1 to 5. Then we have 0, so 0 minus x2 minus 5x3. We have 0 plus 0. This is 10, so minus 10 x3. Now we have the x3 one value, so same by in the way in Gauss elimination we do now by back substitution. So we can start from the lowest. So minus 10x3 is equal to 5, and x3 is equal to minus 1 over 2. Now for x2 we have minus x2 minus 5 x3 is equal to 2. So minus x2 minus 5 x3 is this one here. You can write here, which is equal to 2. So when you solve it more, you will get minus x2 plus 5 by 2 is equal to 2. You have to get LCM, and you will get here x2 is equal to 1 over 2. Then for x1, this is x1 here, which is 1. x1 plus x2 plus x3 is 1, so x1 plus 1 over 2 minus 1 over 2 is equal to 1. So you will get x1 is equal to 1. So what we did today, we start from the Cramer rule. For example, in Cramer rule is saying that when determinant not equal to 0, it has a unique solution. And this is let's say one linear equation. First, you have to find the determinant. Once you find the determinant, then you need other value for x1 and x2. And those ones also you have to do it by determinant. So how you will do it? Just you have to change the columns. EF, this constant matrix, EF, just change the column in dx1, you will get the determinant, then same change another second column in dx2, you will get another determinant. So just divide those determinant by the main determinant you get here, you will get the value for x1, x2. Same for the 3 by 3 matrix. In the first D1, first column, then second column, third column, just divide by each other, you will get the answer. And here is the ILU factorization, which has lower and upper triangular matrix. So you have to make this by the row elimination method. And these are the values of these row elimination which you apply your operations. Just change the sign, you will get the lower triangular matrix. And then you have to suppose one matrix which is Z or Y to make this matrix complete. Put it in the equation, solve the formulas, put the values, and you will get to the x1, x2, x3 or xyz values. So I mean we almost finished most of the linear system methods. So if question asked in the exam, so it will be specifically asked that solve this set of linear equation by this method. For example, if it's mentioned solve the set of equation by Cramer rule, so you have to do this. If mentioned by Gaussian elimination, do this. If mentioned LU factorization, method is changed. So for every single method. Also for the inverse, we studied two types of inverse. One is identity matrix solving and the other one was determinant method. So for every question, it will be mentioned in the method will be specified. So you have to do that method only which is asked in the question.